I'd just like to quickly introduce the next speaker, Andrew Caines from the University of Cambridge, who will lead a discussion on using data. So I hope Andrew is with us already. Yes.
Hello.
Okay. I'll hand over to Andrew. Thank you very much.
Thank you. Okay, hopefully you can see my slides. Thank you for the introduction. Oops. So just a little bit about myself to start with. I'm a member of the Outer Institute, which is based at the University of Cambridge, and it's funded by Cambridge Assessment. And it stands for the Automated Language Teaching and Assessment Institute. So very much about natural language processing and machine learning for the purpose of the topics that we're discussing today, really. And I mean, probably like many of us here, I've been using data and sort of working with data in a practical way for a long time. At first, in terms of corpus linguistics, and then gradually moving across to more like computational approaches, and now really, like I said, working at the intersection of machine learning and NLP. So as a result, I work with many types of data, so everything from linguistic data to behavioral data and student data and so on. So today in this interactive workshop, I'll give an overview really of sort of how data collection and analysis are sort of relevant to us in terms of language testing. Also, I'll just look at some good practices in terms of data management, and also some case studies of data science in practice, and some of the things we tend to do in our research in Outer. And sort of then also obviously setting this in the context of AI for education, which is really, so hopefully follows on nicely from what Mark was talking about. I'll briefly look at some ethical considerations, although I know there are other sessions which really go into that side of things in more detail. And then finally, if there's time, there'll be a brief sort of interactive bit, which really is just going to be question and answer session from you, from the audience. So so just to sort of pause for a moment and check that we're all talking about the same thing. So when we're talking about data, it's obviously a very broad term. So really, you know, you could be talking about many things when you're talking about data. But of course, in this context, we're talking about education data, and obviously, specifically data that goes with language testing. Okay, so any data you can collect that's around that that domain. And so, you know, the first question you might wonder if you're going to think about data collection in terms of language testing is wondering what you might collect. And you know, the short answer really is to collect everything you possibly can, sort of caveat data protection issues such as the GDPR in the UK, and perhaps some ethical considerations as well. I mean, definitely some ethical considerations, but perhaps they sort of come into play in terms of what you can and can't collect. So yeah, that's obviously the very brief answer, but to sort of to think about it a little bit more carefully, if you have some kind of language testing platform, which here I'm assuming that it's some kind of digital platform, okay, but it could be sort of analog, it could be a testing center, which I'll talk about briefly later. You want to collect every interaction of an individual with your platform. Okay, and here, when I say interaction, again, this is very broad. So, you know, lots of different types of data could fall under this umbrella. So we're not just thinking about the actual linguistic input or exchange between between the candidate and the examiner, or the AI examiner, but we're also thinking perhaps about the kind of data that goes with the different skills we're looking at. So, for example, if it's writing, you might collect keystrokes, as in sort of the productive typing a candidate does, as well as the deletions. You know, so the editing process really of the writing process. If you're thinking about listening, then it could be, you know, how many times did they play the recording? What was their response time? As Elaine Schmidt was talking about in a previous session, if you're looking at reading skills, then of course you could be collecting eye tracking if you have the right devices. Okay. So then, so my focus really here is to think about how you can collect it, and then what we can do with such data. So whatever your data is, what kind of things can we do with it? I'll just quickly pass over some good practices in terms of data storage and retention. Obviously, you want to think about access control. So, you know, which members of your organization should be accessing what. And so you might be particularly careful with personally identifying information, such as names, addresses, date of birth. You know, so if those 3 pieces of information could be put together, they could obviously be used for, they could obviously be leaked and obviously used for negative purposes. So you might think about sort of keeping that kind of data in very top secret storage, which only very privileged, with only very privileged access. So really, once you've got that in place, I mean, I think that's really obviously fundamental to think about the security side of things, because obviously we're all responsible for people's information once they start interacting with us. But then we might think about what kind of analysis we can be doing. And of course, there are many different audiences we might be wanting to reach. So firstly, you know, there's obviously a need for statistical understanding of your testing data. You might want to pass your data to machine learning researchers or practitioners who can then sort of train AI models to make predictions in new scenarios. Or you may want to sort of summarize and sort of digest the data, make the data digestible for test developers or management, or even the general public, of course. So there are very different reasons that you might be analyzing your data, and of course, the tools and the way you analyze the data will change dramatically for each one. So I'm just going to recommend a couple of articles if anyone wants to read a bit more of the background. And if you haven't seen this already, these are a couple of articles from Frontiers in Education by Alina von Davier and colleagues. There were 2 articles actually that came out very close together. And one is called Computational Psychometrics. So really that's probably, you know, that really is a good reference given the last talk by Mark. And data cubes is really the one that's probably more relevant for this talk. Okay, so I'll just show you an image from that article. And so what we're seeing here is a data cube, which is that's the purpose of the article. It is to describe such a way of sort of thinking and visualizing your data that you're storing about your students or your candidates. Here you see a 3-dimensional object, they're very careful in the article to emphasize that even though they call it a data cube, it actually could be any number of dimensions, but obviously 3 is sort of the limit of what we can visualize. So here we're looking at the year of the test, the name of the individual, and then the topic being tested. Okay, and the object on the left is the big database, if you like, and the extract on the right is what they've extracted in terms of data of interest. Okay, so then each cell, each block is a data point. And they refer to this kind of operation as slicing and dicing. In the article, they also talk about drilling and pivoting. So I think, if you want a bit more of a sort of conceptual framework for how you're capturing and working with your data, I think that's a really useful article. And yeah, I have no personal involvement, so it's not a personal plug, but just a good thing to look at, I think, sometime. Okay, so now I'll just talk about some of the ways you could use educational testing data. So obviously, the first thing you might want to do is how well students are performing with your test. So here on the y-axis, we've just got a test score from 0 to 10, and you sort of see a normal distribution. These are 10,000 artificial data points randomly generated around a normal distribution. Okay, so obviously this is just the kind of thing you could probably do quite quickly in Excel or R or something like that. But of course, be careful to always really get to know your data. So what's the variance behind the summary plot that you want to produce? Okay, so you can produce a box plot which tells you the headlines. So if you look in the middle, all of those box plots look the same for each group. But if you look at the raw data and the violin plot, which is a distributional density plot, you sort of see how those same box plots can hide, or they can represent very different distributions. And so it's just really, again, this is fake data, but many of you will know about bimodal distributions, even trimodal distributions. So you'll know that it's very important to really get to know your data almost point by point, if you like, before you start summarizing it. Okay, because you could be hiding some very important phenomena, I think. Okay, so obviously another kind of thing you can do is to figure out how difficult your different assessment items are. So at Cambridge Assessment, for example, they measure the difficulty of an item, which is a score between 0 and 100. You've got the discrimination, which is how well an item correlates with overall test scores. So that goes from -1, which is negative, which is a inverse correlation, to +1. Okay, so a very strong correlation. Facility is the proportion of learners getting an item correct. And I'm sure that, testing organizations all over the world are doing something like this, if they're not doing exactly the same. You can read more about it in one of the SILT volumes, the Studies in Language Testing. And yeah, I just want to thank Mark Elliott for talking to me about that. Okay, but then you might also think, all right, so again, those are the headline statistics, really. Those are the fundamentals that you want to know. But also you could do more nuanced things. You could, for example, you could look at the attributes of the items and then look at how difficult each type of different attribute is. So for example, what skill is being tested? Is it listening or speaking? Is it careful listening? Is it close reading? Is it sort of summarizing skills? What's the task type? Is it, do they have to write an email, or do they have to write a job application letter? Where does the item come in terms of the order of the exam, and so on? Or of course, you could be looking at demographic properties of the students themselves. So there's lots of different analyses you could be doing there if you knew that kind of information. or even other data about the exam, such as information about the text, the source text that went into preparing some of the items, who the item writers or the authors of the exam were, what was the level, and so on. So far I've probably been talking to you about things you already know or are very familiar with. So just for the next few slides, I'm going to talk about more like the machine learning AI side of things, which again, you're probably familiar with, but perhaps, in perhaps less of a practical sense. So here's an example where we might want to know how a student, we might want to predict, how a student might perform on new test items. And we can do that based on what we already know about our items and students in general, because of the data we've been collecting carefully over the years or over the months that the platform has been running. So this allows us to then take a new item and sort of say, right, we predict that the student will pass or fail or, score 5 on this new item. This slide has got a bit mangled, but you can roughly get the idea. I mean, it's not really something to worry about too much in detail, but essentially we're looking at what student item data really will look like in terms of a table view. So you've got different students in the rows and you've got different questions in the columns. And we're sort of saying, right, if we know that student 1 passed question 10, for example, then how do we expect them to do on question 20? And these are obviously just random IDs that you're giving your questions. So, well, you might have expectations about increasing difficulty of your questions, but I'm not assuming that here. So we're just sort of saying, with some new question, which has an ID, a random ID, do we expect them to pass or fail? And this is this table of data is just obviously a preview of a much bigger database, and it comes from a student project. So this kind of predictive ability allows us to develop adaptive education technology. So the kind of things we can do then is to figure out which items should come next if we're in a sort of testing or teaching environment, right? So many of you will know about learning-oriented assessment, for example. So you could think about personalized teaching or computer adaptive testing, like Mark was talking about. And really, it's a way to sort of navigate students or candidates through your item bank or through the curriculum. And so we're preparing something like a recommender system, right? So if you think about your favorite TV streaming service like Netflix or something, it's always trying to recommend something to you based on what it knows about you and its other users, right? And its whole bank of items. So let's say, again, here's this kind of fictional item bank of many items. Each circle is one of your items. And here we've got an expectation of increasing proficiency as we go from left to right in our curriculum. And so traditionally, your classic exam will involve some kind of selection from your item bank. So you might pull out 6 items, for example, and they'll be testing a proficiency range of some kind. But of course, it'll be fixed in advance. And so therefore, your student, you will know about your student's performance within that proficiency range. So obviously then the benefit of adaptive testing is that it lets you go beyond that preconception. So it allows the student to sort of skip ahead and reach higher levels or lower levels of proficiency than you were expecting given the exam. And if you think about teaching, then it's a similar scenario. They can sort of try an item of increasing difficulty, and you might push them back to a lower level if they fail a certain item. Okay, so here we sort of see the student being pushed around your curriculum until you can sort of, I guess, give them some kind of scaffolding, some kind of support to reach a certain target level of proficiency. So that at a high level is the idea of adaptive testing or adaptive teaching. So like I said, this fits in with the learning-oriented assessment framework, which is associated with Neil Jones and Nick Saville. So they've written about that at length. Here's a kind of schematic of how you move a student around an LOA cycle, and you're sort of constantly observing, updating your information about the student, and making new decisions about what activities, what items to give to the student. Or in terms of adaptive testing, many of you will know about LinguaSkill, which is a Cambridge assessment exam with some adaptivity. So there, with some kind of fixed number of questions, you can adaptively figure out their level across multiple CFR levels. So just to quickly pause and think about ethical issues, because of course we should always be keeping that in mind. I think nowadays then there obviously needs to be some justification for why you're collecting what you're collecting. Like I said, you should be very careful about how you store it. Also, of course, you might want to think about how long you want to keep it. And certainly in terms of GDPR, there's a need to delete data if an individual requests that you do that. So then there's a kind of question of, well, which bits of the data do you delete? Can you do it thoroughly throughout your whole data science pipeline? I don't know worldwide if that is also true, for other countries, but certainly these are just some examples of other data protection legislation in other countries. But yeah, certainly for Europe and the UK at the moment, we have that requirement. So another question I think is probably just simply more ethical rather than legal, or it might be legal as well a little bit, is whether the candidate actually understands, the consent form or the terms and conditions that they're being presented with. So if they're signing up to use your platform and you're going to collect personal information about them, have you presented that information to them at a suitable proficiency level, or even in their first language? And I think probably, legal language is pretty complex at the best of times. And so this is probably something we could all, be more careful about, I think. Okay, so just in a moment, I'd like to switch to question and answering, please. That's I'm just saying that to the session moderators. But yeah, so here are some sort of conversation starters, but feel free to ask me or talk to me about other stuff. But for example, if we want to make it interactive, you might think about a scenario. So whether that's going to be an in-person exam center, or whether it's entirely online, like a phone app or something like that, or some kind of hybrid scenario where actually you have some teaching in person, but also regular online testing. So I've just got some questions about that to start a conversation. You can feel free to talk to me about your ideas, or just ask me questions about this presentation. Okay, so yeah, I've got about 5 minutes. So yeah, feel free to post questions or put your hand up. I've got one here in the chat. So what has been the most useful model for language research and testing? So for example, regression models or K-means, etc. Obviously, RASH and multifacet RASH are hugely useful in language testing. But beyond that, question mark, and so I guess that's the question. Yeah, that's that's a good one. So I think probably Mark Elliott, who presented before me, would know more about that last question. So the idea of sort of moving the Rasch model beyond the language testing context. But certainly we've done a bit of work with that in terms of adaptive learning and sort of so-called skills embeddings. So that's work by Russell Moore, who's in our group for his PhD. And he's looked at trying to represent student knowledge by sort of learning from the historic data, like of the type that I was talking about. And as it happens, he's using the a multi-component latent trait model, which I think is Rasch. Yeah, it's Rasch inspired. And of course, Mark himself has done lots of work on that area as well. And then I guess to go back to the first part of your question, which model is most useful? Yeah, I mean, I think most often in practice, we find that regression models are pretty robust. So, for example, if you're trying to predict a binary outcome, like will the student pass or fail a certain item, then it's pretty hard to beat something like logistic regression. But of course, the larger your data set grows, the harder it becomes to actually train that kind of model in practice. So that's where we start to see neural network classifiers becoming more tractable, for example, or even taking inspiration from other work in terms of recommender systems. So so the area to look at there is known as collaborative filtering. And again, that's a pretty sort of efficient way to handle large data sets. So I hope that kind of answers your question there. So just a couple of minutes now. Here's another question. Do you believe that AI will be able to efficiently assess writing in the future? Will it ever replace human-based grading in the near or distant future? What are the odds? Well, I'm not a gambling man, but I think I would still back the human in many cases, particularly when it comes to looking at obviously content and semantics. I think that's still pretty hard for machines to model and to understand, although yeah, rapid progress is being made in NLP and machine learning. In terms of assessing people's grammar and sort of obviously spelling, vocabulary, grammar, essay structure, we're pretty good at that already. I mean, with AI technology, it's pretty good. So just to give a plug for Write and Improve, this is an online essay practice system for English, and it'll give you a score, associate a CFR level with your practice essay, and give you error feedback about what you wrote. So yeah, I guess I would actually hedge my bets since you're asking about odds, but certainly I wouldn't worry about completely replacing human-based grading as yet. I think probably the two need to work in tandem in a sort of hybrid setup. That's probably the near future, at least. Yeah, so it's not just Cambridge Assessment, but other organizations like Pearson, obviously Duolingo, are using AI for assessment, as Douglas Lovett points out in the chat. My time has apparently run to 0, but no one has stopped me yet. So I don't know if everyone's gone. Hi.
Hello, Andrew. Yes, no, we're still here listening intently. So yes, the time has run out, I'm afraid. Just to say thank you very much for your very interesting talk, and there are lots of interesting comments in the chat coming in. which may be pursued outside this session during the break. There is now a break of 20 minutes before the LAMI session, so hope to see you there. So once again, thanks very much, and hope to see you in another session soon.